Hi everyone, this is Aditya and Subhashri. Our project is called From Pixels to Products. It is enhancing the fashion discovery with the visual search. So, the modern fashion landscape presents many clothing and accessories with intricate designs and unique features, which are very difficult to verbally articulate. This difficulty and providing user-centric recommendations for the images that they are searching is the main motivation of this project. Fortunately, the internet offers a vast repository of these images thanks to big data for helping us store these images. Our idea in this project is to propose a deep learning based system to identify visually similar images within the fashion domain. This eliminates the need for precise description of the images that the user is searching. This system not only benefits the users but also benefits the retailers by making the users uh, shop what they want. Project workflow. The dataset is collected from the Crawl Feed website, which provides us with Fartech fashion dataset with more than 18,000 rows and the attributes associated with these data. This dataset is then pre-processed so that it can be fed into the model and can be used for the exploratory data analysis. Even though we don't use much attributes in the data except for the images, it is necessary to understand the nature of the data. So that's why we are performing exploratory data analysis and the pre-processing with the CSV file. For the feature extraction, we are using VGG16 and ResNet50 and comparing the results with both the models so that we can understand which model performs better in our dataset. Finally, the best performing model is then deployed to the server using Streamlit, which provides us with a better UI so that the user can have a real-time experience. Finally, a query image is uploaded and the similar images are displayed. So let's talk about the dataset. As I said earlier, the Fartech Fashion dataset has more than 18,000 records and the attributes associated to it. Those attributes are price, gender, availability, brand, title, and the link of the image. Fartech is basically not a retail shop, but it serves as an intermediate between all the retailers and the users and provides users with many options. So the dataset consists of two types of images. One is a cutout image and the other one is a model image. So cutout image primarily focuses on the product alone and does not have any background or other information. The model image, on the other hand, consists of both the product and the models. So coming to data pre-processing, as I said earlier, this step is very important to perform EDA and model training. As a part of data pre-processing, we check for the null values in the dataset and the correctness of the data types of each attribute so that we don't miss out any crucial data. The most importantly, since we are training our model on the images, it was very important for us to have images of equal length because the feature extraction model can only take images of uniform length. So coming to exploratory data analysis, we plotted the top 20 brands from the data with no surprise that we can see Gucci and Baroche, the most famous brands in the datasets as well. But surprisingly, we saw that the products in the dataset were only associated with women gender and there were very less amount of products which are associated to the unisex. So giving it over to Subhashri to continue the further slides. Thank you.
Hi everyone, this is Subhashi Dinesh. Moving on to how our model works, we've used two models, VGG16 and ResNet50, to extract features from our dataset, which consist of over a lakh of data points. We save these features in NumPy files, and then we also pass the query image into the same model. We then extract the features from the query image as well. Now that we have the features of both our query image and our dataset, we can now perform our similarity tests. In our case, we are just using distance metric and we've used the Euclidean distance. And now these features are now ranked based on this distance metric. The lower the distance, the higher the rank. Now, moving on to how we evaluate our model, we couldn't evaluate our model based on traditional metrics like accuracy, precision, or F1 score. This is because we do not have ground truths for our data. And hence, we used other metrics like the time taken to extract features and the distance scores. On the right side, we can see two tables displaying the time taken, and distance scores. On the first table, we can see that VGG16 performs better than ResNet50 by 1 second. And on the second table, we can see that the distance scores of VGG16 are lower than ResNet50. In both the cases, we can see that VGG16 performs better, and hence we stuck to VGG16 for our project. Moving on, to have a better user experience, we also developed a server where we can input our query image and the top 10 recommendations just pop out along with their scores and the time taken. Now let's move on to the website demo. This is our website, and we can just paste a link of any image that we want here. So I am just picking a black boot. We just copy the image address and then we paste it here and hit search. Now we can see that the query image is being displayed here, and once the similar images are fetched, they'll be displayed here as well. And now we can see that the images similar to our input is also being displayed here along with the names and the score. And at the end, we also have the time taken to fetch these images. So that was our user interface. Now, in summary, our project entails the development of a visual search engine using the FireTech dataset. Throughout our project, we encountered several challenges, particularly in the evaluation phase. The absence of ground truths posed a hurdle, preventing us from utilizing conventional evaluation metrics such as accuracy, precision, and F1 score. So, looking ahead, our proposed future work will involve the creation of a baseline training and generating ground truths based on this baseline. We aim to enable the evaluation of our model using these traditional metrics. This approach will enhance the overall assessment process. Now, that's our data mining project, and thank you.